Yeah, go ahead,
Okay.
Jasper. Good luck.
Good luck.
Hi, everybody. I hope everybody is having a good evening. This evening, I'm going to talk a bit about an introduction to virtual networks, and as Wim said, also focus on virtual network peering. I'm going to place virtual networks in an enterprise architecture, which is called the hub-spoke network. I'm going to do a bit of a drawing and a demo on that. After that, I'm also gonna talk about service and private endpoints. How can we use them, and how can we especially use them to our advantage? So my name is Jasper Minnaert, and I'm an Azure consultant at Wortel Belgium, previously known as Synergix. I'm also a Microsoft certified Azure Solutions Architect and a Microsoft certified trainer. I have about 5 years of Azure infrastructure experience, and I'm an absolute Azure addict. If anybody wants to connect, you can always send me an email on my corporate address, which is jasper.minnaert@wortel.nl, or you can just hit me up on LinkedIn. So the agenda for today, we're going to start off with talking a bit about what is a virtual network and how do we place this inside the whole Azure ecosystem. How do we implement virtual networks in a secure way for the enterprise in the hub-spoke architecture? And then I'm going to do a bit of a whiteboard, a drawing, and then a demo of the drawing. After that, I'm just going to talk a bit about service and private endpoints, what they are, what are the capabilities, what are the limitations, especially what are the limitations of service endpoints, and how do we solve those with private endpoints. And then I'm going to do a bit of a demo of that as well. So virtual networks, what is it? Yeah, a virtual network is just something that you can deploy Azure resources such as VMs and web apps and databases in to let them communicate securely. It provides connectivity to the internet and also your on-premise environment. You can think of it a bit just as the legacy networks we used on-premise, but in Azure. And it has a few capabilities and limitations. One of the capabilities is the isolation. So a virtual network contains an IP address space which can be divided into subnets. And each subnet also has an IP range that is part of the address space of the virtual network. You can attach DNS to the virtual network, or you can use the Azure DNS. So it has complete isolation. It cannot communicate to anything outside the virtual network. We can do on-premises communication with a virtual network. When we deploy a virtual network gateway, we can set up a point-to-site connection, which is just an old school client virtual private network. We can also use a site-to-site connection, which is a connection you do to your on-premise environment. You need a piece of hardware for that. You connect Azure with that piece of hardware, and you have an encrypted tunnel, which essentially extends your on-premise environment into Azure. And then you can also deploy an express route, which is a dedicated route from your on-premise environment into Azure. This is unencrypted because it doesn't go over the internet. It's just a private dedicated connection. Another capability is that you can route traffic in virtual networks. So you can define user-defined routes. So you have control over the traffic, which makes it very secure and very manageable. You can filter traffic with, for example, network security groups, which are miniature firewalls where you can allow or block traffic. You can attach these network security groups to, for example, a network interface or a subnet. And then a bit of a contradictory statement is, of course, that virtual networks are isolated. That's one of their inherent properties. But we want to isolate certain resources that belong together in a virtual network. And then we want to extend these networks to each other. And we do that with virtual network peering. And I'm going to show this all in the hub-spoke architecture. So I'm going to draw out a little bit of a hub-spoke architecture in Whiteboard, and then I'm going to do a demo, and we're going to test the connection between two VMs that are in different spokes, so in different virtual networks. And then we're going to create Azure firewall policies. We're going to peer these networks to a hub network. We're going to create the route tables. And then we're going to test the connections again. And hopefully they will be able to talk to each other. So can you see the whiteboard?
Yeah, it's visible.
Thank you.
Yeah, all good.
So the first thing we do is deploy a hub network. So I have a hub VNet, which is, for example, 10.1.0.0/16. And in that VNet, I have 2 subnets. Let's call this our virtual network gateway subnet, and this our firewall subnet. I also, this is the enterprise, so I have an on-prem environment. And in that on-prem environment, I have a large amount of VMs, and I have a large amount of clients. So I extend this on-prem environment to Azure through the virtual network gateway. And I use a firewall to route traffic between my different spokes. So I also have, for example, 1,000 web VMs that host a huge intranet site. So I want to put these in isolation, those web VMs. So I create another virtual network. So this is my spoke 1 virtual network that has a 10.2.0.0/16. I have 1 subnet in that. Let me just call this spoke subnet 1, and that contains, for example, 1,000 VMs. Now, I have a client that wants to access the intranet site. So that client is on my on-prem environment. So it puts in the URL, and we go to the for example, site to site or express route into our hub network. Now, this is a problem. I can access the web. The virtual networks are not connected. So I create a peer between these 2 virtual networks. Now, the client can easily access the web, and then the web just returns the data, and the client now has the website. However, I have 1,000 virtual machines for the web, so obviously we also have a few databases. We want to put these databases in isolation as well, so we can control them. So I create another virtual network for that. So let me just call this spoke2 and do 10.3.0.0/16. Create another subnet. We have, for example, 20 VMs here. And this is the database part. This is the web part. Now, the client asks for the website again. So here we go again. We go to the hub. The hub knows, OK, the website is here. Now, this spoke wants the data from the database, but it doesn't know how to get to that data. So we could do this. We could create a peer like that. But the problem is, if you have 500 virtual networks, this becomes unmanageable. It's not secure. You have thousands of networks that are peered. Nobody knows which network is peered to what network. This is a big problem. You want to control the routes. You want to control all the traffic in one place, and that is the hub. I want to control my traffic in my hub network. So what do? We kill this peer, and we peer the hub to spoke2, which contains the databases. And I create a firewall rule that says, OK, sorry, somebody's at the door. I'll create a firewall rule that says, OK, the traffic that comes from this network has to go to that network. So now we have that rule. We have to create we have to create 2 route tables, because this connection those peers are non-transitive, which means they do not know each other's address spaces. They do not know the IP ranges of the subnets. So we have to create a route table here that says all traffic for 10.3.0.0/16 has to go to the firewall. And here as well, all traffic in this route table that goes from 10.2.0.0/16 has to go through the firewall. So now our networking is complete. So if the client asks for the website, it can go tippy to the firewall. It goes to the web. The web says, hey, I want the data. So now the route table sends it back to the firewall. The firewall says, I have a rule that says you have to get it here. And because it's stateful, the firewall, it goes back. And now we just do our route back, and the client has the website, and the data comes from the database. We do not have connection between the different spokes, but still we can get all the data. We have full control over where the data goes in the firewall. So this is a very secure and isolated system. So let's just set this up in the Azure portal. Let me just get it here. So ignore the endpoint virtual networks. Those are for later. But I have a hub virtual network. As you can see, this is the address space. Then I have a spoke virtual network. This also has 10.2, so the same as in the drawing. And then I have 10.3/16 for my spoke 2. So my hub has a firewall deployed already because it takes a long time. So let's check this out. So I have a VM here, which is my spoke 1 VM. And this is in my spoke 1 VNet. So this has 10.2.1.4. And I have another VM, which is in my spoke 2 VNet, and that has the IP address 10.3.1.4. So I'm going to ping this. Yeah, we have no connection. Of course, all VNets are still isolated. There are no peers. There are no route tables. There is no firewall rule. So the first thing we're going to do is set up our firewall rule. I have an Azure firewall deployed here. So I'm going to create a firewall rule. Just select a collection group, which is just an administrative group. And I'm going to try to ping. So I'm going to try to ping from my spoke 1 virtual machine to my spoke 2 virtual machine. ICMP is the ping protocol, all ports. So I'm going to create this. This is going to start adding a rule. So let's try every step to do the ping. No, I still can't ping because, of course, I have no connections between the different VNets. So let me go to my hub virtual network to peerings, and let's start creating those peerings. So the first peer I'm going to create is to spoke 1 from the hub. I'm going to allow traffic to it. I'm going to allow traffic from it. I'm not going to use virtual gateway because I have no on-premises connections. And then I'm going to go back to the hub because it's a two-way connection to spoke 1 and back from spoke 1 to the hub. I select my virtual network that I want to peer, and I click add. I do the same for my spoke 2. And then back to the hub. So, and I select spoke 2, I click add. So these are being created. Let's just wait for a second. It's always a bit hit or miss in Azure. So, okay, the first one is connected. Let's check out the second one. So in the meantime, let's just test our connection again. Can we ping? Okay, we still can't ping. Of course, spoke 1 doesn't know the address range of spoke 2. So we have to tell it in a route table that everything that has to be sent to spoke 2 is forced to the firewall, and we have to do this for spoke 2 as well. So, okay, those are connected now. So let me just create the route tables. I'm going to create them here and in West Europe. One route table. So that's the first one I create. And then I create another one for the second spoke. Europe. So that's the spoke 2 route table. Okay. So let's refresh. Okay, still deploying. Azure's a bit slower than usual. Okay, our first route table is available. So let's create our route. So to the firewall, so everything for 10.3.0.0/16, send it to a virtual appliance, which is our firewall. And that one, so I'm going to check the firewall IP address real quick. Then that 1.4. And then I'm going to associate this route table to my spoke 1 and to the subnet that my VM is in. So, okay. Okay, so that's good. Let's refresh this and see, okay, we got our second. Let's create the route to firewall. So everything that's destined for 10.2.0.0/16, send it to the firewall, because we have told the firewall what to do with it. We have created that ping rule. 10.1.1.4. And we're gonna attach it to a subnet. The spoke 2 subnet where my second VM is in. Okay. So if I go back 1 second to my whiteboard, what have we created? We have created, I'm going to use the rainbow pen for this, a firewall rule that says if ping comes from spoke 1 and wants to go to spoke 2, the firewall rule will know that it has to go to spoke 2, because we have created that rule. We have created a route table for spoke 1 that forces all traffic destined for this to the firewall, and we have done the same on the other side, which forces all traffic for this to the firewall. So now these are connected. Spoke 1 and spoke 2 are connected, but they are not connected to each other. They are connected to the hub. So fingers crossed, because, you know, always bad luck. This should, oh, this doesn't ping, which is of course a problem. So let me check out the route table. So spoke 1 to the firewall. 1.1.4 is our firewall IP address. Going back to, yes, that's correct. The peers have been set up. So that's a bit of bad luck. They are connected. And then we only have a firewall policy. Is the policy created correctly? Then 2, SMP. This is weird, should work. Bconfig. Ah, here we go. So as you can see, let me just put on. Now we can connect to that virtual network through ping, and it's all routing through the hub network. So now we have created a secure hub spoke network where we have control over the traffic. We can monitor all traffic. It's fully isolated. The spokes cannot directly talk to each other, which is a good enterprise implementation. So the next thing I want to talk about is service and private endpoints. And by default, many Azure services are directly accessible to the internet. They have a public IP address, especially many PaaS services. One of the goals in the enterprise would be to only allow traffic from a certain subnet in Azure, for example, or an on-premises subnet. And when you activate a service endpoint, the routing table of the subnet is updated to route traffic only to the service endpoint instead of to the public internet. So if it remains a public IP address, but the traffic is routed on the Azure backbone. So you have a few advantages that come with that, but there's you can also use a firewall on certain PaaS services, so you can block public IP addresses, or you can allow public IP addresses, or you can allow a subnet. One of the disadvantages of service endpoints is that it retains its public IP address, so you don't get a private IP, which means if you have, for example, an on-premise environment and you want to access, let's say, a storage account, because I'm going to use that in my example, you still have to go to the internet because it remains a public IP. And you can also not select any custom DNS from the main controller or a private DNS zone in Azure, because, of course, it's a public IP address. And Microsoft created an evolution on that, which is called, first I'm going to show the endpoints that are available, the services that are available with service endpoints. So you can see here, for example, we have the biggest services are present, like Azure Storage and SQL Database, Cosmos DB and Key Vault, Service Bus. You can see that here. But Microsoft, of course, recognized that this wouldn't work. This was impossible for the enterprise. Started developing private endpoints. This is essentially the same, but a network interface is created for your service. So you get a private IP, which means that you can now route traffic from your on-premises over your site-to-site, over your express route, directly to the private IP, which is known because you can use a custom DNS, your own DNS, or a private DNS zone in Azure. So it's very fast and very secure because it never has to go on the internet. The public IP is not necessary anymore. Just a little remark, network security groups are not applied to the private endpoint network interface. So the availability for private link, which is the service, the resource that hosts the private endpoints, it's bigger. So you have more services that you can use with private endpoints. And I especially want to point out a service here, the private link service. So if you develop a service in Azure, you can attach it to the private link service and create a private endpoint, which means you can access your service directly on a private IP, which is, of course, very important for the big enterprise. Well, there are advantages, of course, to that system, and that is that it's very fast because service endpoints as well as private endpoints travel on the Azure backbone, even though it has a public IP with service endpoints. So it's very fast because we all know how fast the Microsoft backbone is. It's more secure because you have control over the routing. You can control the architecture. You can control where the data flows with private endpoints. And of course, you have less employee overhead because you have a simpler architecture. So I'm going to do a little demo on creating a service endpoint on a storage account. and then we're going to allow and deny public traffic. And then I have a VM, which is in a virtual network, and then we're going to allow that virtual network to access that storage account. And then we're going to see if I use my personal computer, which is directly connected to the internet, if I can access that storage account. And then we're going to try it with the VM if I can access the storage account. And then we're going to do the same with private endpoint. We're going to create a private endpoint, which of course gets then a private IP. We're going to take a look at the DNS resolving, which comes with the public Microsoft DNS resolving. And then we're going to configure our own DNS. And then again, we're going to hope, fingers crossed, that the private endpoint works and that we can access the private IP directly. So let's get into that. Let me just show you the network configuration. So I have an endpoint virtual network, which contains a virtual machine, and we're going to allow the access from to the storage accounts to this virtual network. So we can test this from the virtual machine. Then I have a private endpoint virtual network. I'm going to deploy a private endpoint there. And then I have an endpoint's domain controller network, and I have a domain controller there that I'm going to use for my custom DNS. So let's check out the storage accounts. I have a storage account for the service endpoint to test the service endpoint, and I have a storage account to test the private endpoints. So I have this document where I have all the data saved for the service endpoint storage account and the private endpoint storage account, so I can easily copy and paste that. So let's begin adding the service endpoint storage account. So this is my Azure Storage Explorer. I'm going to use that to test all this. So I'm going to start by attaching my storage account with account name and key. Go, and then this is my key. And I'm going to connect. And I'm going to open this, and I can see the log, so I can, hello, MC to MC. I'm going to create this blob. Oh, okay. Can't use spaces. So I can create and I can access this. Let me go to the firewall of this storage account, and you can see allow access from all networks. So if I can authenticate to the storage account, I can do whatever I want. So now let me go to this is my VM, which is in the VNet that I'm gonna later on allow access to and deny public access. So I'm gonna add this storage account. So here we go. And because I have no firewall configured, I should be able to see hello MC to MC. So I can also access this. Now let's create a service endpoint. So I go to my virtual network where my VM is in, because I want this connected to the VNet that my test VM is in. I'm going to create a service endpoint. I'm going to add it. The service is going to be storage. I'm not going to use policies. I'm going to add it to this subnet. So now it's being created. So let's go to the storage account again. This can take up to a minute, so we'll have to wait about a minute for the service endpoint and a minute for the private. So I'm gonna do selected networks. I'm still gonna wait for my endpoint to be created. Just a minute, drink some water. Here we go. So now we have this, which is great. So now I want to add an existing virtual network, allow this. Okay, this is correct. So now I have allowed this virtual network to access this the storage account, but I block public access to the storage account. So let me go to my computer. So this is just my computer connected to the internet, and I'm going to do a couple of refreshes. Just refresh it again. It takes about 10 seconds normally. I'm gonna try and create a blob test. Okay. So this is blocked, selected networks, only this endpoint is saved. Refresh it. Okay, so I'm way too impatient to think an IT or trade. So I can access this. So public access is blocked, and I will go over the service endpoint to my virtual machine that I have allowed access on and refresh it again. Create a blob container, test it. And you can see now we're going over the service endpoint to the blob container, and I have prevented access from outside. I can only access the storage account with my virtual network that I selected. I just want to take a quick look at the DNS settings for this, and this resolves to a public DNS, which is the Azure Public DNS server. It accesses it on the public IP address. So I said earlier, you can never change it to a private IP address for a service endpoint. You need a private endpoint for that, and we're going to try to configure that. So I'm going to detach the service account here. Detach it on my local computer. So detach. And I'm going to attach the private endpoint. Storage account. So here we go. So this is the key. I'm going to connect. Let's first check, do we have a firewall? No, I have allowed all access. So I should be able to read this and create something. Okay, let's do this the same on my virtual network that is connected, and my virtual machine that is connected to the virtual network. So attach this storage account. Here we go. Let's fill in the key. And let's connect it. First, let's check our DNS, which this is the DNS for that storage account. So let's do an NS lookup on that. Yeah, we're still on the public DNS and we're still using a public IP, and I can access it easily. So now let's block all public traffic and only allow traffic from a private to a private IP address. So here we go. Let's create a private endpoint. So my priv endpoints. I'll create it in West Europe. Next. This is filled in for me. This is something you have to know, that you have to create a private endpoint for each subtype. For example, for storage account, if I have blobs and I have files, I would have to create 2 endpoints. So I'm going to use blobs to test this. And then I'm going to deploy this in my private endpoint virtual network, and I'm going to use my own DNS. I'm not going to use a private DNS zone because I have a domain controller ready for that. Here we go. And this also takes a while. So in the meantime, let's block all public access to that storage account. So here is the firewall. I'm going to allow access to selected networks, and I'm not going to select any networks. And I am also not going to select any public IP addresses. So if I save this, I won't have connection to the public IP address of that storage account. So let's save, and then let's test. Of course, we have to wait 10 seconds again until. So that takes a bit of time. Okay, so yeah, we're blocked. And if I go to my virtual machine and do the same, we don't allow public access, so it should be blocked, and it is blocked because we are still using the public DNS and the public IP of the storage account, but you can see the private endpoint is being created. We have a CNAME, which is now private link. So let's check if that is already created. Do we have it? Okay, perfect. So refresh. We now have a private endpoint. So let's check out the private endpoint in our private link service. And here we go. We have a private endpoint. And as you can see, it now also has a private IP address. But how do I make sure that we go to the private IP address? I have to use a custom DNS. And I do have that right here. I have a domain controller right here. I'm going to use this domain controller to route traffic to my private endpoint. So I create a new zone, a primary zone. And the zone is going to be blah.core.windows.net. Going to allow updates. Here we go. Now we have a zone, and we're going to create an A record with an A record with the name of our storage account, and it has to be the IP address of our storage account. So let's get that. Here we go. So go back to the domain controller. Oh, didn't copy it correctly. It's always hard to copy things from the portal. You always copy 100 terabytes of data along. So that's 10.7.1.4. Okay, that record is now created. So now we have to set up our virtual network to use the domain controller. So let's get the IP address of the domain controller. And let's set this up in our endpoints VNet, which hosts my virtual machine that the storage account is connected to. So I'm going to use a custom DNS. I'm going to save this. Now I have to reboot my virtual machine. That's an Azure requirement. So let's restart this. Let's get the public IP of our VM, because that's the way how I connect to it. So here we go. This can take a few seconds to reboot. Here we go. Remember the old days when you had to reboot a server? It took 10 minutes. So first thing we're going to check is what is our DNS server. Okay, now we're not using the public DNS anymore. So that's good news. So let's resolve DNS of our storage account. Let's do that. Okay, so now we're going to the private IP address, and I'm just going to quickly show the storage account again. The firewall, I have blocked all public access, so nobody can access it on the public IP address. I only allow this private endpoint to access this storage account. So if I go back to my server, you can see this is the private IP address of this storage account. So, okay, let's go to storage account. So it's still attached, our storage account. And now, again, fingers crossed that this works, of course. Here we go. We have access to our storage account on the private IP address. Yep, so that works. So that was the demo for service endpoints and private endpoints. I hope you got something from this high level presentation about service and private endpoints and the implementation of a hub spoke architecture. If anybody has any questions or if I can help anybody out, just send me an email or add me on LinkedIn. I think Wim said no questions right now. So if you have questions, maybe later.
No worries. If somebody has a question for Jasper, just unmute and ask it. I didn't see any questions pop up in the chat, so